start. Okay, so look at question number 1. Question number 1. Ben wants to design a way to move a heavy box around across rough ground. The box cannot be damaged as it is moved. At what point in the design process should he focus on the importance of protecting the box? What do you think? Winter?
I think it is in the building a prototype.
Building a prototype. Okay, why the prototype?
We need to focus on the prototyping because the prototype must not damage the box as it carry the box.
Okay, so let me ask you a question. If I told you that I want you to design and build a parachute that lets me jump off a building, okay? Now, with this parachute, one of the major things is I do not die, okay? That's the major bit of the parachute. But we go to a situation where you go, okay, so here's the prototype. Now, go. What happens if I die? Not good, right?
Yes.
Okay, so I would say not the prototype. So I don't think a prototype is the correct step, okay? Remember, what did we say that we need to do when we are engineers? We need to look at 2 things. Winter, what do you think it is? A, B, C, or D?
I think it is B.
B. Why B?
Ben needs a material that is strong and doesn't make any damage to the box when it moves.
Okay, so we're identifying a need, right? What's another word to say we are identifying a need? Trixie?
The word is criteria. Criteria.
Yeah, you're right. Yeah, awesome. Criteria. So remember that when an engineer looks at designing a problem or designing a solution, it's going to look at the criteria and the constraints. So one of the criteria of this design is that the box must not get damaged. So the criteria come before any steps, okay? But when you start designing your solution, before you sit down with your pencil and your paper, the first thing you're going to think about, what is that box going to need to do? What do I need to do with that box? It must not get damaged. Therefore, one of the main one of the reasons you're going to build it is to make sure the box does not get damaged. So that must always come first. So identifying the needs, okay? Right. Next question. That took a long time. Errol wants to design and build a structure that will protect tomato plants from heavy rains while still letting in sunlight. Which idea would best help him meet his goal? A wooden case, mosquito netting, a clear plastic box, cardboard covering? Can someone please, Baldy, let's give me the answer, please.
I think we need a wooden case.
A wooden case that's going to let sunlight in. No, that's not good. Billy?
I think it is a clear plastic box.
Yeah, a clear plastic box. Clear plastic box, still going to let sunlight through, but still going to protect the plants from heavy rain. Wooden case, Baldy, not going to stop. Okay. Okay, let's move on. 2. Lonnie drops a carton of eggs while helping her father unload groceries. She decides to make a new type of carton that will protect the eggs better. What is the first step Lonnie should take in the design process? Identify the solution, think of a solution, build a prototype, build the design. What's the first thing she's going to do? Let's go Thailand B.
I think identify the problems.
Yeah, good job. I agree with you. Why Thailand B, stay there. Why do you think it is identify the problem? Why do you think she needs to identify the problem first? Yes, Hacker. Or sorry, Winter.
Because if she doesn't identify the problem, then she can't think of a solution.
Yeah, if she doesn't know what the problem is, how's she going to design a solution? It's like asking me, imagine you're a baby. How do babies learn how to walk? They see other people walking, right? So they can see. Their problem is, how do I walk? What's the first thing I need to know? It's like, okay, well, how do I actually walk? And then you think about what the solution is. So first of all, she needs to identify the problem, which is, how do I keep the eggs safe? Okay, moving on. Question number 4. A company decides to design and produce a new type of ice skate. Which of these should the company do first? Evaluate the new skate design. Identify a need for new skates. So the prototype of the new skates. Test the design of their new skates. What do we think is the first thing that they will do? Let's go, Hunt.
A.
A. Why A?
Because if they knew what a new skate, ice skate to do, they will know what do they need for the ice skate and what is the prototype of that ice skate.
So you think that the next step is to evaluate the new skate design, that they've already designed it, right?
Yeah.
Okay. I would disagree with you. Winter, what do you think it is?
I think it must be B.
Must be B. Why must be B?
Because if we didn't identify a need for a new skate, how do we build it?
Yeah, okay. I would agree with you. So I would say it is B, to identify the need for a new skate. The reason being is that if you do not identify a need, something new, something different that it's going to do than the old skate, it's just the old skate, isn't it? It's not a new type of skate. It's still the same skate that you've just changed the color of. So first thing you would do, in my opinion, is you would identify the need for it. Identify what is going to be different. What is this skate going to do differently? How is it going to be different than the old skate? You do this, you identify how it's going to do that, then you start to design. Then you start to build the prototypes. It's always the identification of needs first. Remember that that is always the same process that engineers will go through. They're going to identify a problem, they're going to look at the needs, the constraints, and then they're going to think about designing. Then they're going to think about making prototypes. It's always those 3 steps first. Okay, next one. Question 5. Camille's family is moving. Camille and her family have several glass bowls they need to pack. Camille designs the way to pack the bowls. Which list of criteria should she use? A. Holds 1 bowl is pretty. Holds many bowls is heavy. Holds 1 bowl is lightweight. Holds many bowls protects them from breaking. Which criteria do you think is the best for Camille? Trixie, what do you think?
I think D. Holds many balls and protects them from breaking.
Yeah, okay, yeah, you're right. I would agree with you. So, look at the question again, and you're going to be able to take quite a lot from the question. Camille and her family have several glass bowls they need to pack. So, you know that several means many. It's not just one. And you know that glass is fragile, okay? So you're looking at limitations here, okay? And you're looking at constraints. You already know some of the constraints of glass are that it breaks easy. Some of the limitations of carrying something, especially when you're moving, is that you don't have a lot of space. So you kind of look at what you need to do and you kind of say, hold on now. What constraints are there? What is a way that I can make this as easy as I possibly can? I already know that I'm going to have a problem with the fact that I've got a lot of bowls and they're made of glass. So what can I do? What criteria can I design and what criteria can I choose to make this as easy as I possibly can for myself? So D, holds many bowls and protects them from breaking, is most definitely a good solution. So these, okay, I'm going to give you these as also probably your homework, okay? So let's look at question number 5, and I'll introduce your homework to do before we finish up, okay? So students designed a ride for a school fair. A school fair is like roller coasters and carousels and things like this. The ride is a cart that rolls down a ramp. The cart must stop less than 15 meters past the bottom of the ramp. The students separately test for design changes. The table shows the test results for each change. So, change. So this is when they change a variable. They put larger wheels on the cart. The stopping distance is 26 meters. They use a rough wheel surface. The stopping distance is 12 meters. More weight in the cart is 18 meters, and used wheels that are wider is 24 meters. So, which solution meets the criteria of stopping less than 15 meters? Noob.
Larger wheels.
larger wheels. These ones, well, that goes 26 meters, so I don't think that's right. I think that's almost twice as far. Yeah, Hunt, what do you think?
I think that use a low wheel surface because if under 50, that's only 12.
So yeah, the rough it is under 15 meters. So the rough wheel surface. For your homework, sorry, what I'm going to do is I'm going to send you a Google form. In the Google form, you have these questions. So if you look at question number 6, an engineer wants to design a knee replacement. So this is basically where the bone in the knee is no longer working. So what a doctor does is they put in a plastic knee, basically, and the plastic knee will then work the exact same as a regular knee. Identify one criterion the design should meet. So if you are writing in the answer to this, I want you to explain the criteria of having a plastic knee and a knee replacement. What does that new knee need to do? Remember, criteria are the needs and wants. So when you are looking at designing something, such as a knee replacement, what do you need that knee replacement to do? Question number 7. Stella and Esteban want to design a sled. They think about what shape of sled would work best on the hill in their neighborhood. Identify 2 design goals Stella and Esteban should set. So what is it that they want to achieve with their design? What does the sled need to do at the end, okay? And give a reason for each design goal. Why does it need to do this? What does the sled need to do, and why does it need to do this? Anyone have any questions?